So just a quick few announcements. I know most of you guys probably heard we're doing Big Data Day LA again this year. The last few years have been phenomenal. We started it in 2013 with about 250 people. Last year was about 550. This year we expect about 800. We started sending out notices for the call for speakers. So if any of you are interested in talking, please definitely submit your talk. We're also looking for sponsors if anyone is interested in sponsoring the event. So definitely that's going to be another great opportunity. There are several meetups coming up in the next few weeks. Next week there's a Spark meetup, and then the week after, on April 23rd, we have another the Lambda architecture. Oh, sorry, it's Spark job talk on why Spark jobs are failing. So that's going to be a great talk. It's in fact by one of the co-authors of Advanced Analytics at Spark. So if you have an opportunity to come, you should come and check out that talk. April 30th, we have another talk on simplifying the Lambda architecture. So if you've heard of the Lambda architecture and what it means, probably it's a great talk to come and understand more about it. May, I'm scheduling talks currently. I have like several good candidates, so you should probably see a few announcements from me over the next few weeks on that. Lastly, I mean, we're also looking for volunteers. If you look for Big Data Day, yeah, we have like close to 40 volunteers, but it's always good to have more so we can get, especially because it's more of a volunteer thing. People can come and help as much as they can, or how much they feel they can. With that, I want to introduce Raj. He's going to come today and he's going to talking about a big data use case. In fact, with one of the big companies in Hollywood, LA. So that's going to be a great thing and understand how they're actually using it. So without further ado, let me introduce Raj and get Raj just to get the ball rolling. Thanks again for coming.
Thank you, Subhash. Can you guys hear me? All right, great. So I'm Raj Babu from Agile ISS, but before I give a little bit more background about myself, let me take this opportunity to thank Rubicon for the venue. It's been great. And also thank Subhash and the LA Big Data Meetup for organizing this event and events like this. It's very helpful. We get to learn a lot from events like this. Thank you, Subhash. A little bit about myself. I've been working in BI for last 18 years. In media and entertainment, I've been working for last 15 years. I've also worked with consumer goods, consumer electronics, online retail in these years. That's pretty much my background. And then I would like to go next into the agenda for this evening for this event. It's big data for media and entertainment and how to meet the analytics challenges and the BI challenges of the industries, not just media and entertainment. The use case I'm going to use is media and entertainment, but this is pretty much applicable to any industry, a large enterprise dealing with a big data problem. All right, let me figure out. When we roll this presentation, when we come towards the end of this presentation, we will be seeing that we are in, there will be a reference architecture for a big data. Any large enterprise interested in implementing a big data reference architecture for them. So we will be getting towards that. It will slowly move towards that, but towards the end, that's where we will arrive at. The format of this presentation is going to be, I'm going to start like 16, 18 years ago. Not because I started 18 years ago in the BI space. It's just because that's when the BI really started taking off. So I'll start from there and slowly build up, and then we will arrive to where we are today. So that's the way, that's the format of my presentation would be. Another main theme would be differentiating, we were in BI before. When I say BI, I'm using reporting generally. So that's what I mean, BI. And then now it's analytics. Analytics used to be kind of, okay, we would like to do some nice things with the data we got, to like analytics is pretty much as important, if not in certain industry, even more important than reporting. So these days, and that's what we will be moving towards. So we'll be moving from reporting, BI, to analytics. So this is, going back 18 years ago. Pretty much, any large enterprise, they had their supply chain management system. They had their own internal application. They had their product management system. They had their CRM system. And then, they had out their external partners that they were working with. And the data, they were interacting with each other through the FTP. The data was moving between them. That's pretty common. Pretty much everybody here should be familiar with it. This is the way, if you worked in the industry that long, you would know this is the way they operated. And there were OLTP reporting systems. So there were like reports run out of these SAP or Oracle Financials or CRM systems. Somebody would write the query and get the data out of it for the reporting purposes. That's how it was done. The problem with that is, very soon people learn, okay, first it was cool because before that it's a green screen. They couldn't even write the query or anything like that. Then they had the ability to run their queries and all that stuff. But the problem was it was interfering with the core function of those applications, be it SAP or whichever application. It was slowing down their core functions. They were not, when the application people were trying to do some updates or writes or whatever, those things, these reports were interrupting with those. So that's when truly really a BI evolved. They saw, okay, clearly there is a need for BI. We cannot definitely, do all those reporting stuff in these various applications. And also we are not able to connect the data between this system and that system. So these two pain points is what evolution of the BI. So they put the ETL things and they built the Data Marts or data warehouse ODS, in Oracle, SQL Server, whatever it is. And then they used one of those popular reporting tools, popular now, MicroStrategy, business objects, and stuff like that. So that's classic reporting. Then the industry moved on, and we are going to come now I'm a little bit going to take the case of media and entertainment, but this can pretty much, if you take your industry, this will apply to your industry. Pretty much every industry in the last 15 years has gone through some kind of disruption, for sure. And the disruption, if you take in the media and entertainment industry, is the digitalization. So they were all having their, very nice heydays, selling their DVD or CD at price point of $28 or whatever. It was with a huge margin and all that stuff. And, volumes were not huge. It was large, big bulk shipments. It moved to digital, the volume, there was a huge explosion of the volume. They still, retrofitted the systems for the digital supply chain. They still used the old BI architecture for this, for the digital too. And it was okay, but still it was, they were seeing the shift coming. They didn't know that the shift is going to come in wave after wave. The first shift, they said, okay, let's throw more storage to this data warehouse. Let's throw more memory or whatever. That will take us through this big bump coming on the way. Then came another disruption with the social media. Social media, it started out, mostly many were not paying attention to it. It was just about, consumers and they interacting, and suddenly it became, from the marketing perspective, it became extremely important. Everybody need to pay attention to social media. Social media is the only way they can know their consumers outside directly interacting with them. What is their preferences, all that stuff. So it was important to take all that social media data and also put it into their system. At this point is really when the analytics started taking off. Until then, if we go before, until then it was truly reporting. Until the digital happened, until the systems were all physical, the CD, it was reporting. They were all, okay, what was my sales yesterday? What was my inventory? What is my forecasting? That's all they were interested in. But when the disruption happened, That's when the analytics started showing up there. Until then, it was pure BI reporting. With social media, it's all about analytics. Now you want to take your sales, you want your social media, what is your, where it's playing, how much they are playing, or the advertisement is watched, and how much it's you're able to monetize out of it. Social media is huge. All this made even more volume of data and more demand on the analytics. And then with the analytics demand, it's like the marketing, they wanted all this data very fast. They couldn't wait. In the standard reporting, you can give them a week later, that's fine. A financial reporting once a month, that's fine. A sales reporting once a week, that's fine. But with the analytics, the demand is high and they are churning through pretty much all the data. They want the most granular data. They are not interested in the aggregated stuff. They are not interested in the rolled up stuff. They want to know at the most granular level what's happening, what is the points at which the consumer is interacting. So the volume of the data is significantly high. So at the same time, the cloud comes in. So the cloud, actually, cloud has been there even before. So cloud has been there in some sorts for like 7 to 10 years, but I think I would say in last 5 years or 4, really in last 3 years, it's been extremely mature. Extremely mature, large organization moving large, complex, secure workload into cloud. So everybody is looking at what cloud can do for me. I have these challenges. I have this explosion of the data. I have this huge analytics demand coming in. All these analytics guys are coming and pounding my standard BI system, and it's causing a lot of pressure in my standard reporting. So how can cloud help me in this? One classic way, at least the organizations I work with, where they are seeing cloud is taking the analytics workload or these variable workloads out of your on-prem, move to the cloud. Because cloud is perfectly built for that. You want 10 nodes, you got it. You want 100 nodes, you got it. You want 1,000 nodes, you got it. You don't have 6-month lead time. You don't need you want the 1,000 nodes for like 3 days, and then you want to turn it off, or 1 day, or 10 hours and turn it off. Cloud can offer you that. There is no way on-prem can offer you that kind of elasticity that cloud can offer. So cloud is huge for BI and big data, because BI and big data analytics is not like BI. If you take BI organizations, they want pretty much standard report. You see, they have a daily report, they have a weekly report, they have a monthly report. It's all pretty set. Analytics is not like that. The data scientists want to know, when they go in, they don't even know kind of what they want. They just go, they wander around, figure it out, they find something, they move on. So the demand in the analytics is extremely variable. And they test some model out, they see whether they get something out. Sometimes they get it, sometimes they don't get it. So it's an extremely variable computing demand. So cloud is extremely suitable for that. And my clients were able to move those stuff to Amazon Redshift. Move such elastic workload to the Amazon Redshift. And then you see at this point, in the previous slide, you will see both reporting and analytics was happening through that standard model. It was going through your data warehouse and stuff. Then with the Redshift, they moved the analytics down to the cloud, and the analytics users were moved to the cloud. And now they can crank up the power for the demand as per the demand needed. And now your BI doesn't have that much pressure. It doesn't have that much stress on it. Move the cloud, analytics to the cloud. So they started there. Redshift was first. Not necessarily everybody have to go in the same sequence. There are different tools in cloud for different business, different organization. They may find something else in cloud might be more suitable in the beginning. But the clients I was working with, because they wanted to they were first used to RDBMS. They wanted to move all the workload from RDBMS to RDBMS, and that's where Redshift is a perfect solution. So how did they move the data from the on-prem, whatever data, Oracle or SQL Server or whatever it is, to the Redshift? if you're going to move all the codes, how many years you developed, 5 years or whatever, it's a huge project. It's very expensive, it's time consuming. One way we did, the easy way we did is we did the replication. There are a couple of popular tools out there in the market. You can replicate using, I think we used Unity. There is, Jay is one of our big data engineers here. There were some Python scripts that was written. So you can replicate the data from your on-prem to your cloud Redshift, couple of different ways. But easy way is that way all your transformation, your ETL, everything you're doing on your on-prem, so that you're not rebuilding everything on the cloud, because that will take some time. Do it on-prem and replicate it to cloud, and then the analytics data scientist can work on the cloud. Then for some parts of the workload, what we did is that we moved it to the ETL, some of the dimension, low volume. We did the ETL from on-prem to cloud. If you're putting a huge workload, don't do that. It's not very effective. But for smaller workloads, it will work. So I would definitely suggest it for some smaller workloads. So that's the way, like dimension lookups, keeping them in sync. Once in a couple of hours, we did that. Data streams. So now, Redshift works. It's good. It solves some part of the problem. The other problem the organizations were having is that archival. Default archival to the data, and then it was going to this passive archive, where once it goes to the archive, unless you put a paperwork and somebody requests it, it doesn't come. You don't do any, unless it comes to the database. Once it's archived out of the database, pretty much if you want it, you don't have access to it. So people were not happy about that. They wanted all the data, so they said, okay, let's move to S3, Amazon S3, keep it in the S3 bucket. That way it's available for us. If we need to load it into the database or do whatever it is, it's available. It's not very expensive. So they started moving everything to the S3 on a routine fashion. So from your data archive system, there was some data taken from social media and even your digital partners and moved into the S3 archive on cloud. Once it's there in S3 archive, what you can do is that you can Hadoop MapReduce and load the data from there into Redshift. And so some of your, so now this is another very important point, because now you're not dependent on, you slowly move some of the data you're keeping in sync on your cloud, Redshift through replication, through the loading those data. You move those data from your FTP or archives directly to S3 bucket, and you use your MapReduce to load that data into your Redshift. So you have moved your workload, and this has, one benefit is it can be, depending on what you're doing, it can be significantly faster than your standard ETL load, significantly. Because usually all these consumer analytics data, what they do, they want the raw data as it is. There is not a huge amount of transformation and anything of that sort involved. So you can move those kind of jobs, you can significantly faster load it using the MapReduce job into your Redshift, and that eases your pressure on your existing ETL load. That's another huge benefit. So we were doing more and more, into this S3 bucket using Hadoop, and then we see what we are doing is really we are moving towards data lake. That is the industry standard. So then we realized, okay, let's take the best practices in the data lake practice, the industry standards, and implement that. So at this point, I'm just going to talk about what is data lake. Data lake is nothing but it's just a reservoir. You move all your data, SQL, NoSQL, into the data lake, and you can actually even consider your Redshift part of your data lake, which is the SQL part of your data lake. And the NoSQL is all sitting in the S3 bucket. So you can run your NoSQL analytics from the data lake. You can run both, and when the workload is needed, you can move it from NoSQL to SQL into Redshift and do that. So data lake is just a collection of the data. It's not. When people load the data into a data warehouse or Data Mart, they don't load everything. But there is always a situation somebody comes back and later, you know what, I want that data. Then they have to put a document, and there's a ETL mapping, there's a development, and after that, historical catch-up. If there is a historical catch-up, it takes forever. If it is there in the data lake, you got the data, and if they have a request, you can do your Hive or MapReduce, and you can get the data probably in a week maximum. There is no way you can do it with that kind of speed if it's archive, passive archive, which has gone to the tapes, or in your, even if they have the data loading into the database through ETL, there is no way that's going to happen. It'll take a much longer cycle. It's a lot more expensive. So that's data lake is. The data lake is, the way they see is your data marts is like the bottled water. It's refined. You will keep some of your water, but keep all the data in an inexpensive raw storage, S3. It's really, really cheap. You can keep how much ever data you want. That way, it's always available for whatever you want to use later. All right, moving on. The next thing we did is that, okay, so the data from the data lake through Hadoop MapReduce was loaded initially on the ad hoc basis. And then we said, okay, let's put some orchestration, let's put some daily jobs or whatever on that so that you have a routine built on that. And that's where we built the AWS data pipeline. With the data pipeline, what you can do is that you can load those jobs regularly. So AWS data pipeline is nothing but you are pretty much doing the ETL on cloud. It starts the job, it sequences the job, pretty much the whole thing. And internally, inside that, you can put whatever scripting you want to do. Same thing with the, so that's the ETL loading into the Redshift, but you don't need to load everything into the Redshift. That's the most important thing. You don't need to load everything into the database. You don't need to go through that expensive ETL process for everything. You can use big data, Hadoop, Hive, and you can write the query. Even if you did not build it something, you want to go and ask it, you can get that query, execute, and get the information you're looking for. So that big data architecture is also available. And this was very popular, extremely popular with the data scientists. They were able to get the, if they're comfortable with the Hive queries, they can go and write their Hive queries and get the data from the data lake. Once we gave the Hive queries, capabilities to the users, what happened is that more and more, this whole way of doing the data became very popular in the big data, and giving the Hive big data analytics to the data scientists became very popular because the very simple reason. If they wanted something through the traditional data warehouse ETL, it's minimum 6 months. You give them, put the data in the data lake, they can go grab it, or even if we have to load it into a database, or if we have to write a Hive query for them, you can get it same thing accomplished. Not in the exact same way, but you can get similar results within 1 or 2 weeks. That's the difference. And it's, so more data started flowing into the data lake. So they wanted to move all the archives, and they wanted to even move everything from the FTP into the data lake. Oh, another thing, oops, I didn't mean to do that. Another thing is that at this point, we also started using Kubol. With the Kubol, what it does is that it manages the entire Hadoop infrastructure. It manages how many nodes we need to open, how much capacity has to be opened. Before Kubol, we need to kind of, you submit it, we don't know, you have to allocate the resources in the Hadoop. You don't know whether it's the right resource you allocated and stuff like that. And when there is a lot more queries or jobs running, then it gets even more complex. With Kubol, it manages the entire thing. You don't need to even know because it assesses the request coming in. Based on that request, it goes and opens the number of nodes or whatever capacity it needs, executes the job. When the job is done, it will go and shut them off. It will submit the results in the S3 bucket, and then it will shut them off. Completely managed, significantly powerful. And same thing, so we started using Qubol, not so much on the MapReduce, but we could very well, because in the client phase, it's just a question of integration, but it can very well work on the ETL part of it, which is the data pipeline. Qubol was implemented on the Hive query side, but it can also very well work with Spark and Presto. And the users love it. They can go into that system, they can see all the historical query, they can share the queries that was executed, and you know, there is a query writing tool too there. It manages the, you know, without Qubol, you submit a Hive query, it may come back. You don't know, it may come back in 15 minutes, or sometimes it may take 2 hours. But Qubol, it pretty much, you know, based on the capacity, since it's boosting the capacity, it comes in a reliable fashion and makes things much more easier for the data scientist. All right. Finally, we are even now, the clients are even moving their legacy systems data into the data lake. So pretty much, data lake, every single data you have in your organization goes into data lake. Here is another interesting one. So the Redshift, so there is a fixed load analytics Redshift, you have it. And then what you can do is that you can get a variable load Redshift, which is another Redshift, nothing. So you had a demand, there is some business proposal, there is some request asked for the data scientist. They want these data to be loaded. You can spin up a Redshift, have it up and running for 3 months. You can spin up it for 200 terabytes if you want. Run it for three months, finish your project, turn it off. So you can have any number of such Redshifts turned on for your capacity, so it's totally elastic, because now you are not stuck with that 200 terabytes when you don't need for 9 months. You spin up the 200 terabytes or 15 terabytes or whatever you want. For the time you need it, you got the juice, you execute your job, you got the results, you got that business done, shut it down. If the demand comes out again 6 months later, no problem. Everything is sitting in S3. You can load 50 to 100 billion records if you want fully in a week or 2 weeks time. So using the the MapReduce, if you want depending on how complex your transformations are. If your transformations are not very complex, then pretty much you can get all the juice you need, and you can run it through that Hadoop MapReduce into the Redshift. So that is that elasticity. So the straight line you see, it's kind of the fixed load. The dotted line you see is the elastic load. So that is something very unique with the cloud. You can do that with EC2, you can do it with Redshift, and you can do with all these solutions. And Qubol too is all pay as you use. Qubol, you run it. If you run it for how many hours you run, you get billed only for that. You're not paying for, it's a subscription. So everything pretty much in the cloud you go, it's pretty much you're paying for subscription. For what you use is what you're paying. There is no capital, you're not going, like just to give an example, the capacity from my client, one of my clients, they went from 100 terabytes to 300 terabytes. For increasing it from 100 terabytes to 300 terabytes, the cost, the investment they had to do with the hardware and software combined was in total about $5 to $7 million. The same thing, they decided no, move to the cloud. They had to pay. Actually, they didn't have to pay any upfront cost, because in Amazon, you can take reserved or you can take unreserved. Reserved, you will have a huge discount in the monthly subscription fee. If you take the reserved, if you take unreserved, you are going to pay $20,000 a month. If you take reserved and pay $150,000 for the same capacity, you will be paying $4,000, $5,000 a month. That's the difference. And you can get the entire capacity within an evening. You can go, you can spin it up, you got the entire capacity you need. You don't need to wait 4 months, 6 months. You can turn it off within 2 days if you don't want it. So that's the key, the elasticity of computing you get with cloud. this is pretty much the reference architecture. So you got your standard enterprise systems, you have your BI data warehouses, you have your external partners. Everything we added in the reference architecture is in the between. You have it cloud. Some companies are not interested in cloud. You want to do this on-prem? Yes, you can do it. Is it going to be as powerful? No, because with on-prem, you're not going to get the elasticity, and you're not going to get the speed, and you have to put the capital investments. With cloud, you don't have any of those. Yes. You know what? I think all other clouds are very soon getting there. I think there are two other clouds. You guys know who I mean. It's Google and Microsoft will be there soon. I think Google with the big data analytics, they are kind of sort of there. Microsoft, I'm not too sure today, but tomorrow is a different story. But everything changes in a day in this space. Today, another thing I like about Amazon Cloud, to be frank, is it's the marketplace. It's not just their product. You can go and get any of the product on already a previously discounted price. It's there in their marketplace. You can subscribe. So you don't need to go and do other software you don't need to go and purchase. It's already there in their marketplace. You subscribe it. You use it for a month, 2 months, done. I don't know if the other providers have a marketplace as robust as that is. So that's one key difference. But from a maturity point of view, whether other two will get there, I think they will get there very soon. Whether they are there today, I don't know. So on the Kubo, it can also work with Hive, Spark, and Presto. So you can work with any of these technologies seamlessly. So that's pretty much, I have 2 more slides and then I'll go to questions. So with the data lake, the key, what are all the benefits of the data lake? Pretty much it makes the entire data in your enterprise in scope. There is no more data, which is what you got in BI is what you can query. No more of that. You can throw whatever you want and everything can be analyzed. The enables easy access to archives. Basically, the archives are no more, archives which is in cold storage, which you cannot access. All archives are active archives. That's something powerful. And then use of NoSQL. NoSQL is significantly faster. Hive is getting, and the technology in that space is getting powerful and powerful. Do I think it will replace SQL eventually? I don't know. But it's taking a lot workload off the SQL. There are a lot of things you can do with NoSQL, which could be done only by SQL before. So it's maturing. Whether it is 100%, no. And I don't think the goal is to completely replace SQL with NoSQL, RDBMS with big data. I think each have their own space advantages. We just need to use them accordingly. But so far, we had only one tool, which was SQL database for whatever we wanted to do. But now we have a lot more tool in our toolkit. We have NoSQL. We have cloud gives the Redshift variable. So we have a lot more tools to solve the problem. And all these lot more tool is not adding cost. If you see, the cost will come significantly low. You can reduce your cost 50% or more when you use these technologies. The latency due to ETL pretty much disappear. That's another thing. A lot of times our clients, they used to load all this data only to discover after a week, the data provider did not provide it right. There were some issues. With the Hive, with the NoSQL, you can run the queries. You can make sure it's of good quality the moment it arrived. Then only even run it through your standard ETL process if you want it. Otherwise, you don't need to even run it. Reject it right there and tell them, hey, fix your data. So those kind of powers, those options were not even available before. NoSQL gives that. And now you don't need to process all your data through ETL. You can use NoSQL to process it. takes pressure off the data warehouse and Data Mart, and then so analytics is moved out. If you see all the analytics people with the data warehouse, usually they would be frustrated. They wouldn't be happy. They're saying, hey, I'm not getting these results. I'm not getting these numbers. Say, you are pretty much taking up all the system resources. Others are affected because of your big query, but they say, still, I'm not getting my results. That's what will happen in that, in your BI databases. You guys can take those pressures out by moving into cloud. Cloud is completely elastic, both in cost and capacity. You can ramp them up significantly up and significantly down within a very short time. And then it offers a pay-as-you-go model. You only pay for what you use. If you don't use, you don't need capital investment. You don't need to go to your big boss for $2 million project. You can go spin up the stuff. Once it's tested, you can prove everything you can do with maybe $5,000, $10,000 budget. Once the results, it shows the results, then you go and say, okay, this is what I'm going to do. These are the results. This is the value. Can you approve the project? With on-prem, you don't have those options. Since I told all the advantages, I thought it would be nice only to say some challenges with the big data. The key challenge with the big data is the talent. Getting the right talent in the market for, pretty much whatever talent is there, it's sucked up by these technology companies. So much demand. So getting the talent is the biggest challenge from the technology development point of view. And then the other side is, I see challenge is the adaptation, because the data scientists, previously they were analysts. Some are savvy. They are willing to go using Hive and all these different queries. Sometime back I was there at Netflix. They call themselves data scientists, but they even move the data. They are doing the ETL jobs. They are loading into the database, and then they are analyzing the data. So they are of that capability. Does every company get data scientists of that capability? It's tough. So human resources is the biggest challenge from my point of view I see in this space, getting the right talent. That's it. Yeah?
And challenges in kind of process management. I'm always a bit concerned about my data lake becoming a data swamp, sort of, where all the users, you dump all the data in there, but someone tries to go back later and there's like a ton of files, Excel spreadsheets, databases, shadow systems, all this other stuff. And it seems like you could very easily back yourself into a corner of, great, we have a data lake, but now we can't really, it's not organized well, or it's difficult to find things in it. And there's a lot of work around trying to organize that or build a process there. Have you dealt with that challenge at all, or?
Yeah, very good question. You saw in my slides before, there was a place I said, I didn't use the word lake. I called it data whatever. The reason, because that was exactly happening. We said there was a point I said there was some structure needed, there is organization needed. You need to definitely apply that. Otherwise, it will become that. You have the data, I just don't know where it is. I just need to search for 5 days to find it. I think, yes, you need to put the process, you need to put the structure, and you need to give personal space where people can move their stuff, because pretty much all the data scientists will need a personal space in the data lake. But then you open the general, because when the data scientists are going and pulling the data, they are going into the main folder and pulling all the shared important data, so you need to protect those too. We cannot lose that. So it needs a clear architecture, it needs a clear security, it needs to have personal space and shared space, monitored and maintained and all that stuff. Otherwise, you have it, you're just going to take forever to find it there from there. Yep.
Where are you storing this data lake? Is it in S3?
Yeah, in the data lake is in S3, and it is also, you can also include your Redshift within the cloud. So I like to call this lake on the cloud. You have your lake on the cloud, and the lake on the cloud has NoSQL, which is S3, and the SQL, which is Redshift. Any other question? Yep.
So my question is, obviously the elasticity of the cloud is very beneficial. The entire purpose of building a data lake is the fact that you can compile data.
Right.
Now that's kind of unpredictable. So from a business standpoint, it gives you the elasticity to turn it on and off. However, how have you been predicting data that's coming in and out and reporting that back to the business in terms of cost? Because it seems like it may be beneficial on one hand and may be incredibly dangerous on another.
I mean, yes, that's a good question. Fortunately, it's not been a challenge. The reason because the cost of storage and processing on cloud, a simple math, is 1,200. If you are paying $1,000 to put everything, the TCO on-prem, with cloud, it's probably 100. With the big data, if you go, so let's take 50 terabytes. The TCO for 50 terabytes on on-prem, cloud Redshift, NoSQL. Very simple math. It's about $1,000 per terabyte per year on-prem. Not more. I'm just you can put even 10,000. I'm just using comparison here. Per month, sorry, per month $1,000 per terabyte on-prem. $100 for Redshift, $10 for NoSQL. That's the numbers we are talking about here. That's the comparison. So there could be some bad habits. There are stuff that we are loading. Because you have such a big gain in the cost, at this point, it doesn't, even though how many $10 you have to have to get to 1,000 or 100. So at this point, it's not a major problem. The cost is, because it's saving so much cost now, it has not become, but once you have started being on cloud and you're monitoring what's going on, that would be a problem.
Thank you.
So you have been talking about 6-month project to days of projects or weeks of project. But the customers are now looking at the data within minutes, within seconds. Has there been any kind of projects which we have been involved, or those kind of projects has been implemented in your infrastructure?
Yeah, I think we are talking about two different things. Yes, everything here, it's minutes, seconds, sub-seconds. From a reporting or analytics performance point of view, you can very much do that. I'm talking about the project life cycle, a development life cycle of a project. If you have to do something in a BI, ETL, that will take weeks or months. That's what I meant. Developing that same project on-prem is weeks. But performance-wise, yeah, you can, there are so many tools available in that toolkit with the in-memory technology and all that stuff. It can be significantly faster.
So can you point out some technologies which are streaming analytics or kind of in-memory analytics kind of technology?
I think so. In the streaming and in-memory analytics, actually, even in the standard SQL Server itself, if you go in the AWS, in Redshift is pretty much it comes to the database. That's it. But what you can do is that you can take that data, extract, and you can put it into the database, or the in-memory technology is available in the cloud, store it on in-memory, and you can retrieve it from there. So yes, in this case, the big data or Redshift per se, are they as fast as seconds? No. But there are things you can build above that which will offer you render those kind of results. But not necessarily the Hadoop and not necessarily the Redshift. I mean, Redshift, if you run a big query, yes, you're going to get it in seconds. But for large volume of data, because the stuff we are talking about here is not about, we have not covered the technologies which is to do render in-memory super fast performance. What we are talking about here is large, huge volume of data, processing them and loading them. But if you want those options are very much available, and you can take these data, put them in-memory. I think Presto, there are a couple of choices you can do. Build above this. It's another layer above this. Same way, like somebody was talking about in-stream. See, this is all batch processing I talked about. There is another part which I have not talked about today. Not covered part of this presentation is some companies need analytics while it's happening. All the online media companies and all that stuff. So those analytics we have not touched upon in this presentation. That's a different topic. That's a different kind of analytics. Pretty much what we dealt with today is in this presentation is batch processing. Yep.
I wonder if you can talk about a little bit the business drivers for the projects. You've done. Is it we hear a lot about cost saving? Is cost the main reason, or is this a new group within the organization that set up their own stuff? Because if it's the cost base, you will see a massive migration from the classic data warehouse to the AWS and the cloud. Probably not too much happening right now, at least at this point. So the business justification for projects like this.
Good question. Yes, there are a couple of drivers. Many companies who have a data warehouse, they are not immediately migrating because not all companies, cloud is still young. Not all companies have jumped into cloud. There are certain industries which are more comfortable moving into cloud. Certain industries, they are still not. So that's one part. The main reason one is cost, definitely. When I'll say it's cost, but here is where that cost comes in. I told about that cost where they had to invest $7 million. They were running out of space for 100. If they already have, so let's assume they have a capacity for 10 terabytes or 15 terabytes. They are in 4 terabyte only used or 5 terabyte. Why are they going to worry about moving to cloud? They still have room of another 15, 10 terabytes to grow. Those companies are never going to move cloud because it's already invested, that money is invested, they better use it. So there is no demand to move there. This is a challenge for companies where there is a huge demand to grow, and at that time, whether you want to invest capital on-prem or you want to move to, so that is the time you make those decisions. If you don't have to make that decision, then probably you're not going to make. Because it's very difficult to go and justify someone who has already invested $2 million on an on-prem infrastructure to say, let's abandon that and move to cloud. So that's one. Another reason where the demand for the cloud and the big data comes in is that if you are not dealing with more than like 20, 30 terabytes of data, really you're not having a big data problem. Like the companies I'm facing with, they are dealing with 300 million transactions a day, 500 million transactions a day. 7 by 24 the loads are running. The system is already at the breaking point every single, and then a huge something comes. They want to load that data. They want to load 50 billion transactions. There is no window to load 50 billion transactions in your BI. Even if there is a storage capacity, you cannot load it. You don't have the window to load it. That's when they move. So to answer your question, it's either they're at a point they need to rethink their strategy where they want to go long term. That's when they think. Or their current existing infrastructure is not supporting the business need, for whatever reason. That's another consideration where they consider to go to cloud. If your clients are happy, if you are able to load all your data that you're getting in on time, you have a capacity for next 3-4 years, probably you don't need to do anything. Just stay there and do what you're doing.
Extending this question, from your experience, which are the industries you feel there are regulations or compliance which will prohibit moving data from on-prem to cloud?
Really, none. I think, pretty much, I've heard one regulation where they cannot. If your company has a business in Germany, Germany has a country regulation where they cannot move the data outside Germany. So that kind of regulation is there. So if you're a multinational, you have data dealing with businesses there, you cannot. Within the US, I think there is no, the federal government is one of the biggest players in cloud. They are moving a lot of stuff to cloud. I don't know if you guys all have followed the news. In 2013, the largest CIA contract for their data center was given to Amazon Cloud. I think it was $30 billion contract or something like that over 15 years or 10 years. So there is government cloud, secure cloud, and you can encrypt your data, and only you will know the keys of your data. Nobody can read your data. You can encrypt your data at a hardware level if you want. There are third-party technology there available to do that. So, you can put your own VPC. You can protect your cloud will be an extension of your firewall. You can completely protect it. So, how much ever your environment is protected, you can make your cloud extension as protected. So there is no limitation. I think there are certain industries, there are reservations. There are a lot of concern with the recent events and a lot of hacking happening and stuff like that. But I think moving to cloud is like it's the utility. 120 years back, pretty much every manufacturing industry had their own power plant. They made their own power to their industry. Computing is like that. Today, all the companies have their data center, like having the power plant at that time. Today, nobody makes their own power. They all go to the grid and get it from there. The cloud will be the same thing, sooner or later. Probably another 10, 15 years, everything will be in grid. Nobody will keep the stuff in the data center. If you are okay with keeping your personal emails in cloud, if you are okay keeping all your personal information on Facebook, well, like, come on. So it's, sooner, I mean, there will be resistance, but sooner or later, that is the direction it's going. It's going to happen. Some may move on the 14th year, but that is the direction it's moving. Nobody can stop it. It's like in the music industry, right? They said, we are not going to give digital music. We are not going to give. Well, you don't give. It's going to happen anyway. They are going to take it. So the industry has to change. If they don't change, then they will just be losing it. That's what happens. That is what this disruption in every single disruptive technology comes. It comes, disrupts the space, and the people in those industries don't have a choice. They have to change. If they don't change, they will just take the hard side of it. Any other question?
You have RDBMS, which is sitting in other servers. So how do you guys test it? Like, how do you guys validate the data? And do you guys use any frameworks or anything else to test validate the data and aggregates?
I mean, the challenge you are talking about is a challenge. I mean, there is nothing specific to cloud. It's a challenge. The challenge, whatever you have in on-prem, is the challenge you have to. I don't think there is any additional silver bullet cloud offers. It's a painful work. It's a dirty work for you to validate. I think it's the same thing. There is nothing. Cloud can give you just more juice to do that whole thing faster, but nothing more than that. I think they saved it. All right, thank you.
So just want to thank Rubicon Project and Byron again for hosting us today, and hopefully we'll get them to host us again. So a round of applause for them.
Yeah, guys, so I'm going to be standing over here on the left side if you guys need parking validation. And if you guys want to talk about data science careers at Rubicon Project, will be standing right there. So please feel free to drop off your cards. Thanks, guys.
Hey, Mark Lafton, you spoke to a colleague of mine, Shane Johnson at Strata, a little while ago.